So thank you very much for coming. Again, Sam Guckenheimer, that's also my Twitter handle. So if you see things you like, my request of you is please tweet #velocityconf, and then the hard part is my name after that with an @ So let me start with a show of hands. How many of you are doing continuous integration? Keep your hands up. If you're doing continuous delivery, keep your hands up, otherwise drop them, okay? And how many of you who still have your hands up are happy with your testing? Okay, you came to the right place. Okay, so that's what I'm going to talk about. This is an experience report. It's about a journey that my team has gone through to get its testing fast and reliable. Your mileage may vary, and I'll be happy to take any questions. If something's not clear while I'm talking, you can raise your hand and shout, and I'll be happy to field it. So a word about what I do. This is the only marketing-ish slide you'll see, don't worry. I work on something called Azure DevOps. You may know it by its prior name, Visual Studio Team Services. You might know its on-prem sibling, Team Foundation Server, which we maintain from the same code base. We ship Azure DevOps continuously as a SaaS, and we ship the server roughly quarterly from that code base. So it's one code base going to both the SaaS and on-prem. So that transition from having an on-prem product, which started about 2006, to DevOps is something we've now been on for about 8 years. We said around 2010 we need to become a good cloud service company, good product as well. We started renumbering our sprints back then. The calendar is still ticking. We have 3 weekly sprints. It's now Sprint 140. So they just keep ticking, and now we have both the server and the service Azure DevOps. And I've been with this actually since we started the server as an idea 15 years ago when I joined Microsoft. Now, in addition to shipping those to customers like you, to external customers, we have the Microsoft One Engineering System as one of our most important instance. So we have about 94,000 active users inside the company as well. They are in some ways the loudest users. And the move to support the One Engineering System on top of Azure DevOps is something that our CEO pays pretty close attention to the extent he'll make it the subject of his monthly town halls. The two colors are that we have both engineering users, about 60,000 of them in the darker band, and about half as many non-engineering users. That is, folks who are looking at code, looking at backlogs, but not actively contributing. The scale of that use in Microsoft for DevOps is that we are now doing about 78,000 deployments per day. Getting to those deployments there are over 300,000 pull requests. There are 500 million tests being run a day. Okay. I'm not going to talk about this at the diversity of the company scale. I'm going to talk about this from the perspective of one product line, but you'll see how that works. Now, I'm guessing most of you have seen the State of DevOps report this year. If you haven't seen the 2018 one, download it. It's fantastic. The thing that it again demonstrates is that high performers move a lot faster than others. 46 times more code deployments than low performers. So that's really interesting, because when you walk around conferences like this, and when you go to DevOps days, there's this conspiracy of silence. No one talks about testing. No one says, well, you know, we got this great pipeline up, and here's how we address testing, and that's really working for us. So, and this hit me at a DevOps Days recently when I led an open space on this. So that's the genesis of this talk. Now, I want to be clear, we sucked too. There was a time when we threw code over the wall to test automation engineers, and then they threw their automation over the wall to testers, or we outsourced testing to vendors. We had split career tracks between SDEs, software development engineers, and SDETs, software development engineers and testing. The test automation was separate from the code, and we typically relied on these long-running, complex tests, often through the UI. And when you have a lot of test automation engineers, you get a lot of test automation. It was kind of astonishing how much test automation we had and how much redundancy we had in it. So you could, if you actually measured code paths covered, you could see, well, gee, that's being hit 10 times. So 9 times is certainly redundant, too much waste, and too much to maintain. So one of the culture changes that we made is we said those test engineers and those development engineers are actually all engineers. And we collapsed the career tracks. So in HR, there was no longer a separate career stage profile for test and a second one for development. And you no longer had this sort of, two-class thing. And you didn't have people saying, well, I'm a test engineer now, but I'd really like to do dev or something like that. We called them all engineers. And then we put them in feature crews, which are multidisciplinary with ops, with a product owner, so they would have end-to-end responsibility for their working feature area as experienced by the customer. This culture change manifests in the change in career ladders. So I think an essential step along the path to get to reliable testing. We also changed what we measure. So we think it's really important to measure everything about usage, everything that customers experience, how quickly you acquire them, how quickly you get them from newbie to dedicated, do any churn, and do that at the granularity of features. We also measure everything about the velocity of our ability to get from change to production. So the time to build, the time to test, the time to deploy, and any failed and flaky test automation that happens along the way. And then we measure everything in production regarding live site health. So if you've been to any of the SRE talks, we're certainly measuring everything about the availability, reliability of the system, and along the way, how quickly can we detect, communicate, mitigate, how good are we at getting from a live site incident to the repair item so that that doesn't happen again. And we measure the impact in terms of specifically which customers and which users in those customers are affected if there is an outage. So we are very conscious of those things. Now, there are a bunch of things we don't measure. And I think this is equally important. We don't worry about how many tests you're running. We don't worry about how many lines of code you're running. We don't worry about your estimates, your capacity, and so forth. And we don't measure code coverage from testing. Big debate, but we have gone through periods of saying, ye must have so many % code coverage. And that, too, has created really bad behavior, where people have focused on hitting that code coverage metric rather than focusing on having the important tests first. Code coverage is great for telling you, here's an uncovered path. If you want to get your code coverage up, the fastest thing you can do is just remove your error handling. Not recommended. So to run as a SaaS in this world, we now have a definition of done where we say, we don't say you have a potentially shippable increment. We don't say it's ready to test. We say it's live in production. Your tests are delivered with your code. And your feature is collecting telemetry that can support or diminish the hypothesis that led to the changes you just shipped. Okay, now we didn't get there overnight. But we think shipping is a feature, and we want to be able to ship multiple times a day. So let's roll the clock back and let me tell you what it was like. I'm going back now to 2014. Remember, we had this service I'm talking about started as an on-prem product. It had not been designed for the cloud. It had not been designed as microservices. It had been largely a monolith. And the testing for it had come from that era where there were long-running tests. So the stats from 2014 for what was then Visual Studio Team Services and its sibling Team Foundation server were appalling. One of the repos had a 60% consistent pass rate on the P0 tests. Another one had a 70% consistent pass rate. And the tests took too long. And then every time these things failed, we had manual investigation. Well, you know, let me check the data was set up right. Let me check the lab was set up right, blah, 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 blah. So developers had no idea whether the changes now in master were in fact good, because all this test running and investigation would take days. And we had this huge quality cliff to make it through a sprint. One of the lessons learned from that old way of testing was to watch your mouth. If you say you have a nightly automation run it means your tests will take all night. In fact, our nightly automation run took 22 hours. Our full automation run took more than 2 days. And that was before all the investigations of those spurious failures. Don't do that. Don't even think that way. So we said, yeah, we need to fix this. And everyone had an opinion. Some people were very skeptical of unit tests, were very skeptical that we could do this. They heard unit testing say, oh, we're not going to do any functional tests. And other people said, unit tests, yeah, love it. And then someone said, well, but what about I need to access the database. Am I going to mock that? And then we got into the debate, is mocking okay? Or, do you need to run the real thing? And the email threads were ridiculous. What we did, and we did this fairly forcefully, I would say, from engineering leadership down, so we said, okay, unit tests are a design tool. You're going to be responsible for quality. You're going to use unit tests as a design tool to make your code testable. You're responsible in that feature crew for your own testability. This was exactly the time we collapsed the roles. You're going to get out of this very fast, reliable tests, and you're going to be able to start them in the pull request flow. Yeah, we know you need functional tests too, so we will have a way of doing functional tests. But by the way, we'll do them at the API. We're not going to touch the UI layer for this. We're going to make everything testable beneath the UI through the APIs. And we used some good guidance from Martin Fowler to say, yeah, well, these unit tests, it's great when you can isolate them and be pure about them, but sometimes you need the dependencies. So to get out of this cacophony, we created a test taxonomy that was non-denominational in the sense of, not something people knew about, and was very simple. L0, 1, 2, 3. L0s were unit tests that ran in memory with no dependencies. And we wanted them to run in 60 milliseconds. L1s were unit tests that could have dependencies on SQL or storage. So this dealt with that, what about my dependencies thing? Then L2s were functional tests that went at the service through the REST APIs, and L3s ran in production. So we just started using the L0, 1, 2, 3 nomenclature as neutral, baggage-free, and it has stuck. So by February 2015, we published a quality vision where we said, okay, our current test portfolio consists of these things we called TRAs, T-R-As, which was a brilliant acronym for test run automation. And these were the things that were so unreliable. And we said, we want to get to a point where we have no more of those TRA tests, and we have primarily L0s, some L1s, fewer L2s, and fewer L3s. We're going to run these consistently. The tests you need to be able to write the test to run in any order with no specified sequencing. You deliver tests with code. You, the feature crew, are responsible for this. And the infrastructure to run them will be part of our pipeline. Now, to get there, we had to start. We had a running service. At that time, I think we had hundreds of thousands of users. And it needed to keep running. And so we needed to say, okay, we're going to keep the old stuff working while we build up the new. So we're going to start writing these L0 and L1 tests. We're going to run those alongside the existing tests. We're going to draw down those existing tests when we see that we can, and we're going to have you write new L2 tests that replace them, and then we're going to add good tests in production. So over the course of about 2.5 years, 42 sprints, we got from a place where we started with those orange bars, which were the old tests, the TRA tests. And after about a year, we had built up enough of the new fast tests, the L0s, L1s, that we could start to draw them down. And then we kept building up the new test portfolio, kept running the old one and drawing it down and retiring as we could, as we saw things became unnecessary. And it literally took 2.5 years before we could get rid of the old flaky tests. We had really strict guidelines on how quickly things were supposed to run, and we measured that. So by September 2017, we were running 55,000 and change L0s in 6 minutes, and 4,000 and some L1s, and the L2s we parallelize, so they all complete in an hour. And I'll show you that in a minute. So let me show you what it looks like today. Okay, so I'm switching out of PowerPoint. I'm here in Chrome. And I am looking at just to show you, I'm going to make this smaller for men and then make it bigger. So just to show you that this is real times or UTC. So this pull request was just checked in. You can see there are about 8 or 9, maybe 10 pull requests that are blue here. That means they are running right now, and their tests are running. And this is live. I'm logged into our production server. It's not. This isn't demo data. And let me make that bigger again. Okay, if I come down and look for the last one that completed its run, you see a little green check here, and I'll open that. This is what a completed pull request build looks like. I'm going to look at the tests. That one ran 84,000 tests. They ran in a little under 19 minutes. If any one of those tests fails, the pull request is rejected. It goes back to the submitter, and they need to fix whatever's wrong. Additionally, beyond those particular tests, you will see a set of policies here that also need to be fulfilled on the pull request. So that, so you'll see under the policies, the third one is what we're just looking at. The build expires in 12 hours unless the other policies are met. Cred scan is a security test to scrub, make sure there are no credentials being leaked in the code. And you see there's this big X near 0 of 1 reviewers approved. All pull requests need to be reviewed. This is required for some of our certifications, as well as something we think is pretty good practice. And I am not going to actually click approve on production on something I don't know about. But a reviewer for that area of code will presumably do that within 12 hours, typically within a few minutes now, and then that will merge to master and trigger a CI build. So that's a successful pull request. Now these blue ones are still running. So if I look at one of them, you'll see oh, that actually looks like it's failing. If we look at one of these, if, say, you are submitting, you can watch your logs in real time as this is running. And if I look at a failure, you'll see, this pull request failed. I go to the tests. I'll be able to see for each test for each pull request, what are the tests that have failed? Here there are 3. They're new. For each test, I'll see what do I need to know to debug this, the error, the trace that's been captured, if this has been run before, history, and so forth. And all of that's available before continuous integration, all through the pull request. Oh, and then I said I'd show you how they move forward to production. So let me take you to our main dashboard. We were just looking at pull requests, this .pr build. We fail about 1 in 5 of those. Okay, so about 1 in 4, 1 in 5. So 25% of the time, test doesn't pass, or approval rejects it, or something like that happens. And that's what these red bars are. The height's how long it took to run. CI usually passes, like 1 in 100 maybe fail of those. And then we have up here these pre-production tests, the L2s I was talking about. The L2s are parallelized in these suites so that they can run faster, complete in an hour. And you will see on top, each of these is a build. So the thing you're seeing is a truncation of 10:02 October 2nd today. And we're now on our, oops, I did not mean to click, 20-something build of the day. Typically, we will see, the build runs green. Occasionally, you'll see a failure like this. Occasionally, you will see, let me see if there are any right now. Occasionally, you will see a yellow box, meaning there's a flaky test. I'll come to that in a minute. If I see a failure on one of those L2 tests. Then again, you'll see the tests, you'll get the error message, you'll get the stack trace. You'll be able to look at what's the history of that test execution. If it's failed, it looks like it is failing several times in here for investigation. Okay, so that is the main flow today. I'm going to show you a little bit more in a minute. Let's talk about the next thing we had to address in terms of getting to a reliable signal. So our friend Martin Fowler of refactoring fame has this great Oxonian English statement on one of his blogs: left uncontrolled, non-deterministic tests can completely destroy the value of a regression suite. In other words, we don't want flaky tests. We want tests that give us a reliable signal where green is green and red is red. And if you have a pattern where this test sometimes passes and sometimes fails, it means one of two things. The test is not reliable, or you have an intermittent failure in the service. Neither of those is acceptable. So we set up a flaky test detector. And the way we do this is we basically take a known good build, and in pre-production, like you were seeing, and pre-production is literally a Azure scale unit, just like production, but with fake identities as test data. We will run the tests 500 times. And if it fails within those 500 times, we mark it as flaky. And then tag work to investigate and fix. We keep running that test as part of the regular automation runs, but we don't count its results. So if it fails, it doesn't actually block the build. And that looks like, that looks like this. So you'll see this partially succeeded on the build, and you'll see here's a test that was marked flaky. And then if I go and look at its history, you'll see, there's this little failure in there. Is this test not reliable? And someone needs to investigate. So we got through those. So now we have tests in the pipeline, and we're going to deploy. And we deploy, and we find, well, there's still no place like production. We have been testing for everything we've known about before, everything we know about with the code, but you can't anticipate the unknown unknowns. So you need to keep going in production to be safe. Your aim's not going to be perfect, no matter what you do. So in production, you need to control the blast radius. Okay? That means you expose a little bit, and then you expose more, and you expose more after that. Now, we do this in two ways. One way we do this is with production rings, which is what these concentric rings indicate. And I'll show you how that works. And then I'll show you the second way. So let's go and look at what's currently being deployed to production. And you will see here, I'll just scroll right. So you can see there are, Chrome refreshes. There have been 2 deployments so far today. Each of these columns is a scale unit. And I can jump into any of those to see what's happening. 5 of these are queued up there. But what is what is this sequence? Let's take a look at how that pipeline's structured. So I hope you can read this in the back. So you'll see here a progression from ring 0 to ring 1 to ring 2 to ring 3 to ring 4 and so forth. Now what does that mean? It means that we start in our canary, ring 0. We start where we're working, where I'm connected right now. Excuse me, and that's the initial deployment. If that's good, we go to ring 1. These are data centers with the smallest user count. Excuse me. So ring 1 is small user count. Ring 2 is data center with large user count. Ring 3, data centers like Europe, Australia with high latency. So high latency to reach, and then the rest. And we progressively expose as we go. So that controlled exposure through rings is one thing we're doing. Let me show you the other thing we're doing in here. If I shrink this back down, you'll see well, maybe you won't. You should see here my avatar, which is tiny right there. One of the things right here is preview features. And if I make this a little bit bigger, you can see I can actually control my access to preview features because I'm inside a preview ring. And we control these with feature flags. So one dimension of exposure control is the to where deployed with rings. The other one is the to whom deployed with feature flags. Okay. So that's how we do progressive deployment. Back to the State of DevOps report. So what we are trying to achieve with this is real continuous improvement, not continuous investigation. That's where we were in 2014. Since then, we've gotten to a place where we really have a reliable signal. Now, a caution also from the State of DevOps report is that when you go on this journey, there's a J-curve. Yeah, great, we're going to do this fast testing. It's going to be wonderful. And you start down that path, and then you say, oh my God, we've got all this unreliable stuff, and it's not really testable, and we need to refactor here, and we need to carve this out into more microservices to be better, more easily tested, and so forth. And you go through this sort of slump. And for us, on this testing journey, that was 2.5 years. So the lessons that we learned are the accountability in combining engineering can motivate the right kind of culture change. Trunk-based development, where everyone's in master, requires fast, reliable testing, where the tests are code, they're delivered with code, they're treated to the same quality standard as code, so that you can get a signal where green is green and red is red. And you need telemetry to measure that you're in fact done when you think you're done, so you see it in production. And you need the executive patience to take the time to do it. So speaking of time, I think I'm out of it. I'm happy for you to come and swarm. And I will point to that URL, aka.ms/devops, which is the website I curate on these experiences. Thank you very much.